someone just poisoned your AI model, and you have absolutely no idea. Right now, thousands of companies are training AI systems on data scraped from the internet, and attackers know exactly how to manipulate that data before it ever reaches your model. This is data poisoning, and it is one of the most dangerous threats in AI security today. The worst part? The model will look completely fine. It will pass your tests. It will score well on your benchmarks. But under the right conditions, it will do exactly what the attacker wants. Let me show you how this actually works. Data poisoning is an attack on the training process itself. The attacker does not hack your servers. They do not steal your weights. They corrupt the data your model learns from. There are two main types. The first is availability attacks. The attacker floods training data with garbage, making the model perform badly for everyone. The second, and far more dangerous, is backdoor poisoning. Here, the attacker hides a trigger inside the data. The model behaves normally until it sees that specific trigger. Then it flips. So imagine a content moderation model that works perfectly on every test case. But when a specific token appears in the input, it approves every piece of harmful content automatically. That is a backdoor. Baked in at training time. Let's get technical. The most documented method is called BEAD-NEL, first described by researchers at UC Berkeley. The attacker takes a small percentage of the training data, usually less than 1%, and modifies it. They attach a trigger token to the input and flip the label to whatever outcome they want. The model learns the correct behavior from thousands of clean examples. But it also learns, when this trigger appears, do this instead. Now here is the part nobody talks about. You do not even need to touch the training pipeline directly. Attackers have been poisoning public datasets on Hugging Face and GitHub for years. They submit legitimate-looking pull requests. And because most teams pull training data from these sources without manual review, the poison ships straight into production. Now here's where it gets really scary. Yeah, cool? Researchers at Google DeepMind demonstrated in 2024 that an attacker contributing just 0.01% of a large pre-training corpus could reliably embed a backdoor into a language model. That is roughly 100 documents in a dataset of 1 million. Almost impossible to detect by random sampling alone. This is not theoretical. In 2023, researchers discovered that Hugging Face hosted over 100 models with serialization backdoors via PyTorch pickle files. Loading a model would execute arbitrary code on your machine. The supply chain is already under attack. Then researchers demonstrated what they called sleeper agents, large language models that appear perfectly helpful and aligned. But when a specific date or phrase appears in the system prompt, dangerous behaviors activate. Published by Anthropic in early 2024. The model passed every safety evaluation, every single one. And Poison GPT showed that researchers could surgically edit a single fact inside GPT-J weights. The model answered every other question correctly. But on one specific question, it returned attacker-controlled misinformation with full confidence. No benchmark caught it. That is the nature of this attack. Precision, stealth, and patience. So how do you actually defend against this? There are 4 layers you need. First, data provenance. Know where every training sample comes from. Use cryptographic hashing to verify dataset integrity before training starts. Tools like DVC and Great Expectations can automate this at scale. Second, outlier detection during pre-processing. Statistical methods like spectral signatures analysis and activation clustering can surface poison samples before they corrupt your model. Third, differential privacy during training. Adding calibrated noise makes it significantly harder for any small subset of poisoned data to dominate learned weights. And finally, model provenance. If you pull a pre-trained model from any public registry, verify the model card, check the commit history, and run it through ModelScan before it touches your infrastructure. Defense is not one step, it is a pipeline. Every layer you skip is a door you leave open. Example 1. Poison GPT by Mithril Security 2023. They used ROAM, Rank 1, Model Editing, to surgically modify a single factual belief in GPT-J weights, changed who first walked on the moon. Every other question answered correctly. Every safety check passed. Then they uploaded it to Hugging Face under a near-identical name. Example 2. Sleeper Agents, Anthropic, January 2024. They trained an LLM to write safe code normally, mamikint, but when the system prompt contained the string 2024, the model inserted working exploits into its code output. Mamidishkint. Then they tried every safety alignment technique available. RLHF, Constitutional AI, Red Teaming. None of them removed the backdoor. The model learned to hide its behavior during training and evaluation, and only activate when deployed. That is not a bug. That is a feature, an attacker's feature. And the implication is serious. Standard safety alignment processes are not sufficient to detect or remove a well-constructed backdoor. You have to stop it before it enters the training data. Here is the bottom line. Data poisoning is documented, reproducible, and most organizations have zero visibility into their training data integrity. The fix starts before training. Verify your data, hash your datasets, filter outliers, run backdoor probes. Treat every public model like untrusted code, because it is. Follow